In this lesson, I'll show you how to solve solution stoichiometry questions. This is question number 2. The question reads, what volume in milliliters of a 0.150 molar of nitric acid solution is required to completely react with 35.7 milliliters of a 0.108 molar of sodium carbonate solution according to the following balanced chemical equation? And then in part B, what mass in grams of carbon dioxide is formed? I want to start by highlighting some important numbers. We're told the concentration of HNO3, and it's right here. We're told the volume and concentration of Na2CO3. So I'll take these numbers and write them underneath the chemical formula of each compound. And of course, by doing this, it helps us organize our work. So we have the concentration of this compound, and I'll represent it by the letter C, 0.150. Remember, molar is moles per liter. It's important that you remember that. And it reacts with Na2CO3. I'll write the numbers here. We're told its concentration, that's in moles per liter as well, and its volume is 35.7 milliliters. Now you have an option here. You can change this into liters, or you can change this number into moles per liter. I'll change this into liters moving forward. So to go from 35.7 milliliters over to liters, you will divide this number by 1,000. And if you do that, you end up with 0.0357 liters. So using these two numbers, I can find the number of moles, and then I can set up a molar ratio with these two compounds so that I can find the number of moles of this compound. It's important that I find the number of moles of this compound because then I can use this relationship, C is equal to N over V, where N represents the number of moles per volume is our concentration. Now if that's confusing to you, let me show you what I mean. I'll start by replacing this C with 0.108 is equal to the number N, which is what I'm looking for, which represents moles, over our volume of 0.0357. If I multiply these two numbers, I will end up with N. So N is equal to 0.108 times 0.0357. This gives me a very small number. We have 0.00385. That's in moles. So I just found the number of moles of this compound. As I mentioned earlier, we need to set up a molar ratio between these two. Notice that there's one molecule of this compound versus two of this compound within this balanced chemical equation. So I'll write down 1 to 2, and I'll write the number of moles down over here. And I'm looking for the equivalent number of moles for this compound. I'll do a quick cross multiplication. This number times 2, x times 1. It's a nice little algebraic technique. 2 times 0.0038556 gives us 7.711 times 10 to the power of 3. Or N is equal to 0.00771. And one more 2 just for good measure. Using the concentration and the number of moles, I can find the volume using this formula once again. I'll do my work up here. I have 0.150 is equal to the number of moles that I just found over the volume. To find the volume, I'll take this number divided by 0.150. So volume is equal to 0.007712 over 0.150. Using my calculator, I already have the number on the screen. I'll just need to divide it by 0.150, and that gives me the volume in liters. But remember, we want the answer in milliliters, so I need to multiply this by 1,000, and I get 51.4 milliliters. Now, all of the numbers we started with had 3 significant figures. This number has 5, although as you can see, I've stopped writing after the 4. In part B, they ask us for the mass of carbon dioxide formed. What I have to do here is find the number of moles of carbon dioxide. I'll use the molar ratio 1 to 1 because there's one molecule of this compound and one molecule of this compound, so the number of moles of CO2 is this number. So N is equal to 0.0038556. And since they're looking for the number of grams, that's a mass, we need to find the molar mass of carbon dioxide. The molar mass will give us grams per every mole. So let's find the molar mass. I'll represent that by the letter M. The molar mass of one carbon atom is 12.01 times 1 plus the molar mass of oxygen is 16 times 2. Let's use our calculator. 12.01 plus 16 times 2 gives us 44.01. 44.01 grams per mole. And it turns out that if I multiply the molar mass with the number of moles, I'll find the mass. Little m is representing mass. So I have 44.01 times 0.00385, and we end up with 0.16. 0.169 grams of carbon dioxide is formed according to this balanced chemical equation. And there you have it. That is how to solve solution stoichiometry questions.